All right, welcome to Chapter 6, Section 4, Elimination Using Multiplication. So in the previous section, for Chapter 6, Section 3, we learned what elimination was and how to use that. In this section, we're going to kind of review that a little bit as far as how to use it when we don't have terms matching up. So just to look at this front screen, you will first see a due date on your student screen. I don't see it on my screen, but you'll see it on yours as a student. We always allow unlimited attempts. You can come in and work on this as many times as you would like. This particular assignment has 4 questions on it. Grading policy is always best score, so whichever attempt is the best one is one you keep. Partial credit is enabled, so if you answer 1 of 4 questions, you get to keep or get credit for the 1 question. Once you start your homework, you must finish it before you work on anything else. So there's a little reminder, and it means if I click on the Start button here, once I've done that, on the bottom right corner, you'll see a Submit Assignment button. It's not here on my screen, but it'll be on yours. As soon as you're ready to leave the screen, even if you haven't worked on anything or if you've worked on a couple, you click that Submit Assignment button. It does 2 things. It stops the system from locking you out, just like that warning said, and it affects the gradebook that way. Otherwise, it just kind of sits open and the system will make you come back to this assignment. It does not reset anything. As long as you've clicked the check button and gotten a green check mark up here, you will not have to redo that problem. So it saves your place wherever you are. If you have something typed in here and you haven't clicked check, it's not going to save that. You have to make sure that you actually click check for it to save. We can see some tools on the side here. So we have a calculator. This isn't always here, but sometimes we have one. Explanation tells you you're going to lose your question attempt because it's going to give you the solution to this question. You're not going to get the solution and then get to come type in the answer. Sorry, that's not how this works. You'd have to come in on another question attempt or another full assignment attempt to do that. Example shows you an example of what we're going to do on this problem to solve it. So once you've read through all this and you're happy with it, then you can close this. You can open another example if you'd like, and you can also message your teacher directly from the screen, asking for help, and we can see exactly what it is you need help on too. All right, so like I was saying, we're going to keep using elimination on this one, but now things don't quite match up. So if you are watching my previous video and if you are having trouble with what elimination is, go back and watch section 3. That teaches you the introduction to elimination so that you understand some of these steps. So with this one, I'm going to do this, and we were color coding this on the last one. So what we want to see is that something matches, either the x coefficients or the y coefficients. We don't particularly care if the constants match. That's not going to help us. So in this case, nothing matches. I have 7, I have 8, I have 4, I have 7. So if I were to subtract straight down, nothing would eliminate, nothing would cancel out. That's what elimination means. So what we get to do is we're going to kind of force something to match. And what you want to do is the lowest common multiple of either the x coefficients or the y coefficients. You basically just choose which one am I going to eliminate. Those are the ones I'm going to make match. Doesn't matter which one. You can choose x or y. Sometimes they work a little nicely with each other, so it's really easy to turn one number into the other. In this case, with 7 and 8 or 4 and 7, that's not true. We're just going to have to kind of multiply by the opposites. So in this one, to make these guys match, like this, I'm choosing the y's. For whatever reason, I'm going to eliminate the y's on this one. So I want the y's to be the same. Well, the lowest common multiple of 4 and 7 is 4 times 7. There isn't anything else that's in common that's lower than that. So I'm going to multiply the entire top by 7. I'm going to multiply the entire bottom one by 4. So now I'm going to end up with 7 times 7 is 49. X. 4 times 7 is 28. Y, and equals 12 times 7, and I'm going to be a little lazy here just to make sure that I'm not messing that up, 84. So we get 84. And one thing I forgot to mention too, if you multiply, since they're both positives, if I multiply by negative, then it fixes that having to subtract issue. And we can add straight down. That's more preferable, adding straight down, because then you don't have to worry about distributing the negative sign. You're kind of distributing it with the 4 here. So negative 4 times 8, that gets me 32, negative 32, x. negative 4 times positive 7, that's negative 28y, equals 4 times negative 4 is negative 16. So now something matches here. We forced it to match. These equations are the same. So this top one is still the same and the second one or the bottom one is still the same. All I've done is increase the entire equation by the same amount, which is our one of our multiplication properties. I can do that. It doesn't change the problem because I can reduce it again by dividing by 7 or dividing by negative 4, and it would bring me right back to these original equations. So now I can add straight down. So 49 plus negative 32, and it doesn't like this because plus negative means minus, okay, equals 17. And then 28 minus 28, well, that's what we wanted, something to cancel out when we did this, equals, and I'm being a little lazy with the calculator here, but that's all right. Sometimes it's all right. So we get 68. And now we can solve for this x because it's being multiplied by 17. So I can just divide by 17 on both sides here. So x equals, let's see, divided by 17 is, it does go in evenly. I was hoping it did. Don't know the multiples of 17 right off the top of my head, but all right, so we get x equals 4. So I know x equals 4. Y, I can go back to any of these equations. It doesn't matter if I use the originals or if I use the ones that I multiplied by 7 or negative 4. But what I want to do is I want to plug this x into something. So I want to replace, I want to substitute x with 4 because I know x equals 4. So I'm going to go ahead and choose that second one there. I'm going to go 8 times 4, because remember x is 4, plus 7y equals 4. So I'm doing this so that I can solve for y. I still need to know what is y. I know the x coordinate of my solution, but I don't know my y coordinate. So 8 times 4, which we already did, the negative version of it anyway, is 32 plus 7y equals 4. Now I'm going to start solving. So I want to move the addition or subtraction first. I know this says plus 7, but it's plus 7 times y. So it's a positive 7 being multiplied by y. So this is a plus 32 or positive 32, so I'm going to subtract 32 from both sides. 32 minus 32 cancels. 7y equals 32 minus 4. So these are opposites. I'm going to subtract. I have more negative than positive, so it's going to be a negative number. Because 32 is definitely more than 4. I'm not talking about bigger than as far as like on a number line or anything like that. I'm saying there 32 is farther away from 0 than 4. So there's more negative numbers than positive numbers here. Divide by 7, divide by 7. 7 divided by 7 cancels. So negative 28 divided by 7 is negative 4. So I'd end up with negative 4. And this is a coordinate. So remember, when we're finding a solution to a system of equations, what we're literally finding is where do they cross here. So if I go back, and I know this was one from the last section, so we want to make sure that we're editing this correctly, because I know I did this on one of the other ones. I forgot to take the negative sign out, and then it was a little messed up for a second. Whoops, just 8. And it doesn't care that these are in standard form instead of y equals mx plus b. This is, sorry, I didn't say this again because I haven't used it on this video yet. It's desmos.com/calculator. It's a very cool graphing calculator so that you can see a visual of your equations. Because this is what we're doing. It's an equation of a line, and we're literally asking, when we say, what's the solution of this system of equations, we're asking, where do they cross? So they cross right here at 4, negative 4, which is exactly what we found when we did this elimination. So this one can still definitely be solved by graphing. It's right there on top of integers. So we could do that for sure. If you're doing it on paper, make sure you're being very, very neat about drawing your lines, because otherwise it won't quite land correctly. You won't get the correct point here. But you can always, use the graphing calculators. Be a little careful about becoming dependent on them, because they're not always going to be available to us when we're doing some of the different types of testing, okay? So that's the only bad thing about becoming very dependent on them, is that we may not understand how to do the algebra that goes with all of this if we don't understand what goes behind the graphing. All right, so with this one, we have some fractions. Ooh, help if I switched around. So we have negative 1/2 x plus 1/5 y equals 11. 3x plus 1/4 y equals negative 3/4. So one thing I would do before I even started this is eliminate the fractions, because it'll make it much easier to look at, honestly. So I want, again, to deal with lowest common multiple, so we're actually going to do that twice. So lowest common multiple here, if I have 2 and 5, I'm looking at the denominators right now to eliminate fractions. The lowest common multiple would be 10. So I'm going to take this guy, I'm going to take the whole thing, plus, sorry, I'm writing really sloppy right now. Let's see, I think I can do better than this. 1 over 2x plus 1/5 y equals 11. I'm going to multiply this entire thing by 10. And I'm not starting necessarily with the elimination yet. I'm just trying to eliminate all the fractions. So I am eliminating, but I'm eliminating in a different way. I'm not eliminating to solve quite yet. This is just going to make it easier to look at. So with this one, I have to multiply every single piece by 10. So negative 1/2 10, that's 10 divided by 2. So that becomes 5, or times 5, so it's negative 1 times 5, which is negative 5. 10 divided by 5 is 2, so 1 times 2 is 2, and 11 times 10, which is just, we're just going to multiply that out. So this equation becomes negative 5x, negative 5, because negative 5, or negative 1 times 5, and then the x is here, and then 1 times 2 times y, so plus 2y equals, and with this one we're just going to add a 0 to the end because we're multiplying by 10. So it's 110. It's 11 tens. That's another way we can think about that. So we had 10 tens in 100 plus one more is 110, right? All right, ooh, don't get rid of that. So the second one, we're gonna do the same thing. We want to eliminate those fractions because again, it just makes things a little easier to look at. So since they both are 4, we're gonna multiply everything by 4 because that will eliminate these guys. So 3 times 4. 4 divided by 4 is 1, and we have 4 divided by 4. That's not a negative, but looks like it was a negative. No, the negative's in front here, so I had actually just hit it again. So this is times 1 again. All right, so now I have 3 times 4 is 12x. 1 times 1 is 1, y equals negative 3 times 1 is negative 3. So now I've gotten to this point where I can go ahead and start kind of messing with some of these numbers a little bit. So if I look 5 and 12, I'm going to have to multiply by 5 on the bottom one and 12 on the top one. So I could do that. Really wouldn't hurt anything. But 2 and 1 are going to be a little bit easier to deal with because this is a 1 here. I can very easily turn 1 into 2 by multiplying by 2, and then I wouldn't have to do anything to this top one. So when I do this one, I'm just going to multiply this whole piece by negative 2, and I'm doing negative 2, so they're opposites. I have a positive 2 and a negative 2. So this guy on top is just going to get rewritten. I'm just going to scooch it over here. And then the bottom one, I'm going to go ahead and multiply by negative 2. So negative 2 times 12 is negative 24x. Negative 2 times y is negative 2y. And negative 2 times negative 3 is negative, or positive. Sorry, 2 negatives make a positive 6. So now, these guys match. This is where the elimination part comes in. I can add straight down. I have negative 5 plus negative 24. I already have 5 negative. I'm going 24 more negative. So that's 29x, negative 29x. 2y minus 2y cancels out. That eliminates. Equals 110 plus 6, which is 116. So now I can divide, because this is being multiplied. So that's my last step here, is just divide real quick. so that I know negative 29 divided by negative 29 is just 1. And then I can go over here and go 1/16, not times, sorry, divided by, go back. Divided by negative 29. Negative 4. So that did go in evenly. So you get negative 4. So now I'm going to plug this back in. I could go back to the fractions and plug it in if I want. I can plug it into these pieces if I want. Doesn't matter which equation I plug it into. Okay. So I prefer to not, do the fractions if I can. So I'm going to plug it into this top one here. So instead of x, I'm going to write negative 4. So I'm going to have negative 5 times negative 4 plus 2y equals 110. So negative 5 times negative 4, that's 20, plus 2y equals 110. Now I want to start getting y all by itself. So I'm going to subtract 20 from both sides. 20 minus 20 cancels. 2y equals 90. 110 minus 20 is 90. Divided by 2. Y equals 45. So y is definitely a much bigger number. Interesting. So we have negative 4 and 45. So let's see, is that good to go? Oof. So yeah, that was just a big coordinate. So remember, again, this is a coordinate like this. So it would be x and y, and that's where the two lines cross. All right, let's keep going here. All right, so now we have some decimals. So we practiced with fractions there. You can eliminate the fractions. You can also eliminate decimals by simply multiplying everything by 100. Because I only have 100th here, meaning one decimal. Sorry, 10th. Goodness gracious, not 100th. We can multiply everything by 10 because we only have one decimal place to deal with. It's a 10th. So if I multiply by 10, everything will just move over. So instead of 1.6, I can write 16 minus 12 equals 64. And then I'd have negative 8 plus 23 equals 36. So if you notice, it's all the same numbers, but all I did was move the decimal over one time for every one. As long as you're only moving it over once, you're multiplying by 10. So I multiplied everything, both equations, by 10 to eliminate decimals. You don't have to do that step, but it makes it a little easier to look at without the decimals. And now if I look at 16 and 8, I can easily turn negative 8 into negative 16, which would be opposites there is what I want. 12 and 23 don't quite work like that. If it was 12 and 24, they would, but 12 and 23 don't. I want to say the lowest common multiple of these two would be 12 times 23, which is going to be a nice big number. So instead, what we're going to do is we're going to multiply this whole bottom one by just 2. Not negative 2. It's already negative. So just be careful with that piece, when you do that. So this top one's not going to change. But the bottom one, it's going to be 2 times negative 8 is negative 16x. 2 times 23 is, 46, not 56. 46y equals, let's see, 36 times 2. I think that's going to be 72. Let's make sure I didn't mess that up in my head there. Nope, 72, we're good. All right. So now I have matching, except that they're opposites. So we want them to match, but we want one to be positive and one to be negative. So 16 minus 16 cancels out. Any number minus itself is 0. Negative 12 plus 46. So that gets us, let's see, 34y. And I subtract, even though it's plus here, because they're opposites. And I have more positive than negative, so it's going to be a positive 34. Equals 64 plus 72. So we're going to get a bigger number than 100 there, 72. Equals 136. And now I can divide by 34, because it's being multiplied by 34. 34 divided by 34 cancels. And I have a feeling I'm going to end up with a decimal here. Let's see. Oh, I didn't end up with a decimal. So we started with decimals. It wouldn't necessarily surprise me, but it's not telling me what to round it to either. So if you do end up with decimals, you're probably going to end up with something that you don't have to round. It's just, be aware of, Alex will tell you to round when it expects you to do those types of things. So now I'm going to go back in and I'm going to plug this into one of these equations. I could also plug it into one of these equations. It's not necessarily going to make a difference what I plug it into, as long as I multiplied correctly. If somehow I didn't convert this correctly over here, then it wouldn't give me the right answer. So 23 instead of y, I'm going to put in 4 equals 36. So negative 8x plus, being a little lazy again here, so 23 times 4 is 92 equals 36. Now we're solving for x just like we have on all these other ones. Trying to get it by itself, so I'm going to take this 92, subtract, because we always do addition subtraction first. And be careful, this is not being subtracted, this is times negative 8. So just be careful about how you read it. Negative 8x drops down, 92 minus 92 cancels, and we have 36 minus 92, so we get negative 56. This is being multiplied, so now I can divide by negative 8. I want to bring the negative with it, because I'm dividing the whole thing by negative 8, because negative 8 divided by negative 8 cancels, becomes 1. And now negative 56 divided by negative 8 is positive 7. So again, this is just a coordinate. This is where this guy would land. Whoops, I wrote those backwards, didn't I? Go 7 and then 4. So I put that guy in the wrong spot, didn't I? And it would definitely mark me wrong for that. So make sure you're paying attention to where you're typing those in, because I should have typed in 4 for y, not x. All right, so we're going to do a word problem here. They seem to like to end these guys with word problems. So remember, when you're doing system of equations, you're going to have two types of quantities that are being compared. So you just want to think about, what am I comparing? And you'll have two different reasons to write an equation. So a lot of the time, I think quite a few of the ones we did, it was like plan 1 or A and plan 2 or B, something like that. It's just two different plans. We've also had one of the ones we did in section 3 was the sum and the difference of numbers. Well, that's two different quantities. One, sum means addition, difference means subtraction. So when you're reading it, you just want to think, okay, what are the two different quantities? So a fruit company delivers its fruit in 2 types of boxes. Ooh, here's our 2 situations. We have large and we have small. So large boxes or small boxes. A delivery of 8 large boxes and 3 small boxes. So this is giving me an amount, a quantity. I know how many boxes were delivered. So I have 8 large and 3 small. And the total weight was 870 kilograms. So now I have a quantity, meaning I know how many boxes were delivered of each. And then I also have a total weight for this. A delivery of 2 boxes, 2 large boxes, and 5 small boxes weighed 102 kilograms. So I have these 2 situations here. And now it says, how much does each type of box weigh? So I can even kind of draw this out if I wanted to, and try to think of it, kind of visually. You can play with the numbers here and try to do, some some kind of smart guessing a little bit until you land on the right numbers. But we can definitely use elimination here. So instead of L for large box, I'm going to use L instead of the word large. And I'm going to use S, I'll put my little crosses on there for the small. So if I add these together, the 8 large and the 3 small, that equaled this weight. Now if I do the same thing for this other delivery, I had 2 large and 5 small. If I add those together, I get this total weight. So I know this is kind of a weird way to write the equation, but it's just showing what do I have. So I can use this type of thing for elimination here. Nothing matches. The L's don't match for their coefficients, and the 5 and the 3 for the small don't match. I can very easily turn 2 into 8, right? So that's the one I'm going to focus on here. So I'm going to multiply this whole thing by 4, because 2 times 4 gets me 8. And not just 4, I'm going to do negative 4. So I'm going to go ahead and write the first equation down. Plus 3s equals 187. And then let's go ahead and write the second equation down. 2 times negative 4 is negative 8L. Negative 4 times 5 is negative 20s. Sorry, 5s times negative 4. And then we have 102 times negative 4. So we get negative 408. So now these guys match, but they're opposites, which is exactly what we wanted to happen. I can add straight down. 8 minus 8 cancels out because it's 8 plus negative 8. Well, one's positive, one's negative. 3 minus 20, that'll get me negative 17s. And then let's go with this plus. So I'm doing this a little backwards. It's negative 408 plus 187. So I'm going to end up with negative 221. So now I want to solve for the s, so I'm going to add 17 to both sides. So 17 minus 17 cancels out. So the small box weighs, I should be dividing by negative 7. I'm losing my mind. This is multiplication. We're dividing by 17 on both sides, so they cancel out. I don't know why I wrote it that way. So dividing by negative 17, not plus, equals 13. So the small boxes weigh 13 pounds. Now I can go back and plug this into either one. So I can say in this one, it's 13 instead of s. So I'm going to replace s with 13. So I'm just using the second one for whatever reason. So I have 2L plus 5 times 13. That's going to equal 102 kilograms. So now I have 13 times 5. Why isn't it working? Times 5. So I get 2L plus 65 equals 102. So now I'm going to use my solving an equation rules. I'm going to look at what's being done to the L. I'm multiplying by 2. I'm adding 65. So I'm going to subtract first. I want to do addition and subtraction first. That usually helps us not have so many, fractions or decimals. If we do it that way, 65 minus 65 cancels out, and we get 102 minus 65, which is 37. And we're going to divide by 2. Let's see, we're going to end up with a decimal, but that might be okay. We're going to continue doing this. So 2 divided by 2 cancels. 37 divided by 2 is 18.5. So let's see if that's correct, because just because it's a decimal doesn't mean it's not correct. Okay, so weight of small box, your answer is incorrect. All right, so what did I forget to multiply here? Two, 5, 102. Uh-oh, what did I forget? 8, 3, 187. So something went wrong with this one is what it's saying. Weight of each small box. Your answer is incorrect. So the large box is correct. Oh, why is there a 5 on there? Ta-da! Okay, so it was okay. I just somehow typed an extra 5 on there, and I didn't notice it right now until I looked back at it. So everything came out okay, like I was saying, just because I ended up with a decimal doesn't mean that it's going to be wrong. I could always check it on another one here. As long as I also ended up with 18.5, it's perfectly fine. All right, so that was section 4. I will see you in section 5.